Back to another video in the series. Last video, we worked on implementing a public key infrastructure. This video, we're going to deal with the implementing of secure protocol. And for our first exercise, we're going to work with the domain name system security, or DNSSEC, and which is really the backbone of the internet, right? Every email that's sent from one client to another client, or every website that's browsed, requires DNS. In the early, I believe in the early 80s, DNS was, I believe, invented to support the internet, right? Which was, of course, in its initial stages. So with the growth of the internet, it started to play a critical role, right? So what we're going to do is actually get a bit into that part of how we can have more secure protocols through DNS security, right? So our first task, we're just going to create a zone. And the DNS zone is pretty much an administrative section of the DNS namespace, which is part of a hierarchy tree structure, right? So the root domain is always at the start, the DNS namespace, and then you can actually have several zones. So each zone actually gives you administrative control for a specific domain, which means that the zone always starts with the domain and can have several subdomains, similar to certificate authorities, right? You have your root certificate authority, then you have your subordinate, at least for comparison, right? So we can actually go ahead and get started. Of course, we want to have the manager here, and naturally we go to DNS, right? So let's actually expand this, or lookup. Let's actually expand that as well, and then create a new zone. Just going to hit next, right? Then primary zone, that's good. All right, actually, let me see. Storage zone, okay, that's good. All right, now on this one, so on DNS servers running on domain controllers in this domain, okay, that's good. So there's a difference, right? In this forest domain, there's the difference there. So I just wanted to confirm, right? So the zone name is going to be here. All right, perfect. Now let me read this one. All right, allow only secure. Yeah, of course. All right, we can hit finish. All right, perfect. So now we can notice that a new zone with the name that we just created, secure.practicelabs.com is now created. So we're good there. So now we're just going to create sample resource records. So before you usually create any resource records, you need to create a zone first, which is what we've just done, right? So now that we created a zone, this is the zone we're going to use to create the resource record. So to do this, we're actually going to head here, right? And then we can see the files here, but we'll get to that in a second. Let's get here. I'm actually going to do two of these, right? So, all right, perfect. Oh, I'm so used to putting the dot. All right, perfect. So that one was created. All right, so now we can do www2, then naturally 0.2. That looks good. All right, perfect. And we can actually hit done. All right, perfect. So now we're just going to create a non-authoritative DNS server, which will install and configure that non-authoritative, if I can say it right, DNS server on for the DM01 device, right? So it's going to be used. It's not going to be used to like resolve names in the lab network because it won't be able to write any writable DNS zones. So it'll be used instead of just storing DNS security keys from DCL1 that we have that is hosting the secure practicelabs.com. So we're just going to be using it for the distribution of the DNSSEC anchor keys. So actually, let me go back here, right? And then let's go to PowerShell. Right, perfect. Right, so now we're just gonna do And I've done this similarly in another video as far as this type of command. All right. Going to collect some data. Oh, no. That was fairly quick. It just confirms success true. No restart needed. Just confirming the successful install of the DNS. So can actually exit out of here. Let's go back to DNS. All right. Actually, I think I already have it open here. All right, perfect. So let's actually, okay. Actually, you know what? But just realized I was supposed to be on the other server with the PowerShell. So nonetheless, let's just go back and do what we're supposed to do. Could have sworn I went there, right? There we go. My bad. It's amazing that this one takes a lot longer, right? Okay. Usually I put us on the other side of it as far as recording wise, but I'll just let it run because it's going not too bad. Hmm. Tiny bit. So now that we have that fully done on the correct server, let's go ahead and enter DNS on this point. I realized I was on an incorrect server when I opened up the DNS manager and I saw the incorrect because I know we had to install it to do what I mentioned before. But nonetheless, let me stop rambling and get to work. Head here. All right, perfect. So let's edit. Of course. Okay. All right, perfect. So we're good there. All right, so this just sets up the 0.1 as the DC server as a forwarder server, right? It'll make sense in a moment. But DNS is going to, it will attempt to resolve this to its host name, DC01, right? And it usually just takes really just a few moments for that to happen. I don't need to wait for it. I just wanted to point that out. But nonetheless, now that we're back in the we're back in the DNS manager. I'm actually going to keep that open because it'll allow us to move on to our next task, which is going to be finding the zone using the default settings. So using this manager, I'm just going to configure the DNS security on a particular zone. So we can actually enable DNSSEC on the zone and distribute the keys with the use of trust anchors amongst the servers and verify the configuration. So the trust anchor, what it is it's a public key, right? That's associated with a specific zone that's been protected with DNSSEC or DNS security, right? So when distributed among DNS servers, the trust anchors form a chain of trust that is useful for validating DNSSEC among servers. So I'm just going to use the DNS manager to find the secure.practicelabs.com zone with DNSSEC using the default settings for DC01, right? So with that being said, let's actually go back here. The manager should still be open, but that's fine. We can open it back up. All right, perfect. Let's actually, all right, let's find the zone. Let's read here. Actually, we want to use the default, right? Next. love when things get done quickly. All right, so let's actually get here. When we refresh, there's going to be a long list of things that populate here. So we see the updated context of the secure zone, right? And now it shows actually also a padlock that's appended to the zone. You see the icon in the zone folder actually. So similarly, the resource record types just have been further expanded to show what resource records are actually signed by the DNSSEC. So we're actually going to minimize these for the next task. So we're just going to distribute the trust anchor to a non-authoritative DNS server. So in the earlier task, when I actually installed and configured this non-authoritative server on the DNS server on DMO1, the purpose of setting that up, right, was to test it to just the distributor for the DNSSEC keys, which is also the trust anchor, right? So among the DNS servers, such as a non-authoritative DNS server and the domain controller that's running as the server, I'm just going to share a trust anchor amongst the DNS servers on this server here, right? So let's see. Alphabetical order. Here it is. There. Go. All right, perfect. We're gonna share this folder. Hit apply. All right, perfect. Actually, let me take a look. See. Oh, okay. But so what I'm thinking, which is why I'm a bit confused. I mean, I know I'm in the system 32 folder, but I was expecting it to say DNS. But nonetheless, we can move forward. I'll just have to mentally note that, right? So actually, let me click close here, and then I can actually exit here. So now I'm just going to connect to swivel over to the other server. Make sure that the manager is open. Let's expand. Let's see the trust point. Do some importing, right? And set secure. See what else needs not be able to. So that's why I keep looking up. I want to make sure. Right. Okay. Uh, I know what it is. I know exactly what it is. Uh, that's what it is because it should have said DNS, but that's what I was thinking in my head. Actually, just in case. Okay, let's fix it. All right, so if we got everything situated, I was able to import the DNS key. So now we can move forward. So let's see if we can actually send this, send that, click on here. All right, so now we notice that the contents of the secure folder displays in these in this pane here to the right. So there are DNS keys imported in the signed domain on the authoritative server, which is DCO1, right? We're just going to keep that window open while we go head into our next task. It's going to be verify the DNS key trust anchor. So after the distribution of the DNS key, right, the TA to the non-authoritative DNS server. I'm just going to test the TA to if it can be detected by DNSSEC aware clients, such as like another Windows or higher version, right? So let's actually swivel over to Win 10, and we're going to use PowerShell. It's not another. Okay. All right. Yeah, we're good. Perfect. So now we're just going to um, that's better. No, something off. Okay. Usually something small. All right, no problem. We're going to fix this too. All right. So I located the issue. Like I said, it's always something very small, missing a dot after practice labs in between practice lab and trust anchors. But now we can see that the command detects and lists the DNS key TA wherever it's found on the network. So the true trust anchors are now listed, each on where does it say here? Should say, but each one is on DCO1 and DMO1. But now this allows us to query a signed zone without the DNS validation required. So now the distribution of the DNSSEC key trust anchor to the non-authoritative DNS server, we had tested to see if the TA can be detected right here by the DNS aware client. So we have Windows 8 or higher version, at least for this lab. So the result of the test with the two trust anchors that were listed, right? And this confirmed that secure.practicelabs.com has been signed without the DNSSEC, the zone, at least. So now we can actually, let's see, type another command. See if I can take the lazy way out. Let's see, do that. I believe that should be it. All right, perfect. So now it's just we're resolving a DNS name in the PowerShell pretty much. So now we notice, so now we see the quiver command, right? So now we should notice that the workstation shows a successful response, right? Here, pretty much we have a successful response, right? The DNS SEC TA is successfully in place in the lab network, right? So now we're just going to verify that the DNSSEC validation is not required, as I mentioned before. So I'm actually going to type a slightly different I, 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 Slightly different command. All right, that's fine. No result is given, but typically that means situations like these, there's not a policy for the DNSSEC validation, right? I didn't get an error, so we're good there. So now I'm able to configure support for the DNSSEC and GPO group policy objects, right? So the name resolution table or policy table is used typically for DNSSEC validation when the DNSSEC aware client queries the DNS server. So NRPT is configurable via a local GPO for a local testing or domain GPO for a domain environments, right? So in this task, I'm just going to configure a domain-based GPO to require DNSSEC validation to query the signed secure.practicelabs.com, right? So for that, I'm just going to swivel over here. So let's close this out. And I want to get back to the third manager. We need to get the new VM. All right, perfect. All right, so let's open this up here. All right, perfect. And then of course, get this here. Of course. All right, perfect. So now we see, let's see, it should be here, but the DNSSEC GPO should be listed. Let's see. There it is. Perfect. Actually, there it is. Yeah. Perfect. So now we see DNSSEC GPO is now listed under the practicelabs.com node here. So actually we can right click here, edit. Then we're just going to expand the policies here, Windows, and should be named resolution. Yeah. All right, perfect. So now open this up. All right, so we're going to do this. Suffix is fine. All right, so let's do been doing all day, secure.practicelabs.com. All right, perfect. All right, so now in this folder, we just want to do that. All right, require the DNSSEC name and address data. All right, so now we can actually create. Perfect. So now we can actually scroll down to the NRPT. We can actually hit apply. Right. And so now with that being said, I can close all of this. I can actually exit all of this too. So let's open up PowerShell, one of my favorite tools. All right, perfect. And then of course, just gonna do a group policy update. Usually doesn't take this long. All right, perfect. Perfect. So now we can see, we can actually locate. Let's see. There it is. DNSSEC validation required. True. That's what we want, right? So now this allows us to move on to another task, which will be the query defined zone with DNSSEC validation required. So to do that, I'm just going to swivel over to 110. And now after setting up the domain-based GPO for DNSSEC validation, we run a query, right, to resolve a resource record on the signed practicelabs.com zone. So let's actually run a group policy update here as well. Okay. Perfect. So let's clear this out. I'm just like working with the clean windows, but let's do that too. And then see. I know it's nothing. Perfect. True. There we go. Perfect. So I like what I see so far. So now we're just going to resolve the DNS name with DNSSEC validation configured. So we'll just do perfect. All right, so as we can see, there's no difference between our early results and now the result DNS name. So this is because there's a valid trust anchor or TA present on the DMO1 server. So the query is successful even if the DNSSEC validation is required. So it was completed earlier via the GPO domain. So again, I like working with a clean window. So let me go ahead and clear this out. All right, so now I'm just going to attempt to resolve again some more research records, right? So let's see, actually I can try to bring this down. That is not where that goes. Okay. All right. There we go. Oh, that's a lot. All right, so as we can see, right, it just resolves the resource records, right, within the secure practice labs zone. So now we can also see that the host, let's see, where did it go? But let's see, the www was successfully resolved. So actually see that should show. It does show, but the www, sorry, the www was successfully resolved, right? So we can actually do some other details also about the host record designer, the signature. There's also another resource record host called ww2 that we also created earlier that we can also query if we'd like as well. Yeah, let's actually do that. I'll do ww2. There it is. Perfect. All right, so we're good there. Those resource records have been resolved for both, even though I just had to really do it for one, but I just felt like both just for personal reasons. So now we can move on to our next exercise. That's going to be configuring IP security. So network protocol security or IPSEC, right? It's a stack of protocols that help to protect the data traversing through a network by ensuring authentication, right? Integrity and encryption. So before data is sent between two devices, authentication has to ensure the integrity of the devices, right, is verified through the use of certificates. So also authentication and usually passwords. So IPSEC just signs the data sent between the devices to ensure that they were not modified, meaning its integrity is intact, right? So we can actually start with our first task. It's going to be creating a connection security rule by Win10. So Win10 or Windows rather, they use a security connection rules that combine IPSEC and Windows Defender Firewall with advanced security. So with that being said, I could go off a little bit more into it, but I'll just get right to what we're here for. The Windows Defender. All right, perfect. Do that. okay. Okay. All right, perfect. Now to computer and user. Right. Okay, we're going to keep those like this, that's fine. And do the ISO isolation policy. Perfect. All right, so as we can see, the ISO isolation policy, or I'll just call it ISO for this video. So the ISO pol has now been created, so we can actually take a look at the properties there as well. Remote computers, right? And then in point one, I'm gonna add here, right? So pretty similar to what we've already been doing here. All right, now also this is the IP address of 110, by the way, so it's referred to as the local host. So when configuring usually connection security policies, the static IP address of the host must be manually entered, usually as we're doing here. Just wanted to say that tidbit. So let's do in point two. Let's hit add, and then we're going to do pretty similar IP here. All right, perfect. So now we could just back on these policies, right? Well, the policy dialog box. In point one, it becomes 0.3, while in point two becomes 1. So I guess that's, well, not I guess, I know that's fine, right? So we can actually minimize this. Now what we're going to do is create a connection security rule for DPO1. So let's actually connect there. So we're just going to hit start, administrative tools. All right, perfect. So let's do that. Pretty much the same concept, right? Same concept. Isolation. I think we did something different here. Inbound, outbound. Yeah. Computer and user. Right. All right. That's good. All right. Perfect. Now we're going to still do isolation policy. This will be the isolation for this. Okay. Now we can finish. Then we're of course going to go into the properties. Premises. Selected. Yeah, I figured that was coming. All right. Good. All right. So we're back on track. All right. So let's keep going here. So of course we're going to add. Right. We're going to do this one here. Right. Then we're going to okay. All right, perfect. So now we can say endpoint 1 is at 0.1, while endpoint 2 is at 0.3, which is fine. So now we're just going to verify the security association. So the connected security rules that can be monitored using the security associations node in Windows Defender firewall with advanced security, at least in this version. So the main mode just displays the establishment of a secure channel between two endpoints to protect the data during transmission. So now I'm just going to actually, let's see, go into monitoring security main mode. Authentication up here, right there. See here, refresh. Should be some hash there. All right, let's fix that as well. All right, so we're back on track. So this is what I was looking for this to appear here. We were just I believe it may have been the lab itself, but I'm not going to harp too much on that. So I'm just going to click quick mode here. I just want to point out, right, that the ESP is used to ensure data integrity using the algorithm, right, the ESP integrity here, using the secure hash algorithm 1, right? And the data encryption is not enforced due to a connection security rule that was configured earlier that we did that indicated request authentication for inbound and outbound connections, right? So, but nonetheless, we can move forward. So now we can take a look at our next task. Is going to be running the network monitor to observe traffic patterns. So the connection security rules, they use isolation, which has been successfully created on Windows OS, right, and Windows Server devices. Now for this task, I'm just going to use a protocol analyzer that I believe I used in another video. I'm not too sure, but for Microsoft Network Monitor to monitor network traffic between these two devices. Most likely, I'll try to maybe use DC and DMO1. Just not entirely sure yet, but it's a network. As far as the analyzer, it's a network sniffer program that can be used for monitoring traffic. You know, for the third time, what it's used for. What I'm going to use it for is just with the connection security will enable for isolation. So I'm actually going to flip it back over to Win10. I did not mean to turn that off. Flip back over to Win10, right? And it's actually type here, Microsoft Network. There it is. All right, perfect. Actually, you know what? Let me run that back really quick. Yep, there it is. And of course, make this a bit bigger. All right. So select, I just want to make sure that Microsoft Hyper-V network adapter was selected for the Ethernet. So now we can actually click here, right? There it is. Got where it was. All right, perfect. So just going to let the network monitor run to capture network traffic on the selected interface, right? But in the meantime, let me click here. All right. Now the purpose of this step that I'm doing with the File Explorer, right, while the network monitor is running in the background, is just to generate network traffic and set the connection security rule and to force the network isolation between DCO1 and Win10. Back on. All right, perfect. So let's see. Let's see. Let's see. Actually, let's see. Good thing I didn't do what I did to DMO1 to DCO1 because I would have to wait and I would be not so happy. So again, what I just did is just to generate some network traffic to test the connection for the security rule. All right, so now we have a new File Explorer window that opens displaying the map network connection, right? So I'll just actually close this window, right? Because I won't be copying files. I don't need to. So actually we can close this too, right? So now I'm just gonna stop here, right? Let's go to the network conversation here. On traffic, we're good. Now let's take a look at the frame summary. If I can make it bigger. kind of sort of, I guess. I'm not going to take too long in that. So it just displays all the data frames that were captured between Win10 and DCO1, those at least those computers, right? So it allows us to move on with our next task, right? To find the network conversation signed with ESP. So when you capture network traffic by default, all packets being transferred over the network are captured naturally, right? So for the review purpose, we're going to filter in traffic. I'm going to filter the traffic in network monitor here. So with the filtering, only the intended traffic is displayed. So for example, we can actually filter the captured traffic with it to view only the TCP packets, right? So just going to use the network monitor find feature to locate the data frames that were signed by encapsulating security payloads or ESP using a security hashing algorithm, number one, which is the SHA. So I just want to also note that the network transmission was not encrypted as defined by the policy request authentication for inbound and outbound connections. So let's actually go into filter. I mean, this is pretty similar, at least to me. The network monitor is kind of similar to Wireshark, right? So let's actually type in a filter here. Yeah, apply. Perfect. So now we see the frame summary pane. It just refreshed, right? Just for a quick second. So data frames that meet the filter criteria for ESP was used to isolate the communication that was displayed, right? So within the frame summary, I'm just going to search for the TCP frame. Let's see, is a good one. Oh, sure. No, actually, let's see if I can make it come out. No, worry about it. It doesn't bother me, but I wish I could just make this portion bigger. But yeah, I'm just going to take a look at the protocol for alphabetical order. But nonetheless, I have one, right? So we're good. I'll just use this one for IPSEC. So so I found the TCP frame under this protocol, right? So observe the frame details, and I'll notice that the ESP should be displayed. There it is. Perfect. So the next protocol, TCP, sequence, things of that nature. Beautiful. All right. So the hex details are also, this should be displayed here also as part of the detection protocol. I'll do encryption rather, not the detection. What is the, let me check another one. Yeah, I'm not sure what the hex details aren't showing, but it should. So actually, let me I can actually take a little deeper look into a new research here. So let's see. Perfect, perfect. So now, right, I really don't like the GUI. It's kind of now. But now we can see on the network conversations, right, that the ESP it has a conversation ID, right, which is 11. So this as a result of me selecting as a result of finding the network conversation that uses the ESP. So now I'm just going to take a look at the TCP node as well. Let's see, just to see the DT here. Gonna have another one here. Yeah, for some reason there aren't any TCP nodes. So it should be, I mean, there's UDP. So why don't I TCP? But nonetheless, subsequently, the frame details, right, is this again. The frame details, it just indicates information about whatever frame you select. So actually, let me clear this out. Right. Right, so I can just get that out the way. So now I'm just going to apply again because I don't feel like it needs one. Nonetheless, let's go back to all the traffic that we had. All right, so now, now we're going to be able to disconnect the connection security rules on the Win10 and DCO1. So what we did previously was we enabled the connection security rules, which turned on the data by signing ESP, and which is part of IPSEC, of course. So when the connection security rules are enabled, both the participating system known as the endpoint, the traffic is encrypted between them. So just enabling, we can also disable the rules for the two endpoints, right? It would make sense. So, however, if we do disable the rules, IPSEC is not used for encrypting the traffic between the two endpoints. So we're going to do is just disable the security rules, which is going to effectively turn off the data signing for ESP. So let's actually go back here, disable the rule. All right, and let's click back here. Let's see. There it is. This one should be, should not enable. Let's see here. Oh, okay. That'll work, I guess. Yeah, that'll work. But nonetheless, now we can run the network monitor to collect new data. So after disabling the security rules that we have monitoring capture the traffic that was signed with ESP, now we're just going to collect network traffic with the same application with the security rules turned off. So let's go back to where the rules are. Let's restore it, and we can hit start. Here's this now, capturing packets, configure running, and then I'm going to do what I did earlier. Just to generate traffic. There it is. Then it's going to be another. Yep. We're not copying nothing, so get out. So I think we did enough, so we can actually stop here, right? Just take a look at all the traffic, right? Yeah, we see the frame summary here for all the traffic we took care of. And this is definitely not the real time. I wish it was, but it is not. So take a look at ESP again for our filter. Let's apply. There it is. So we disabled the connection security rules, right, for DCL1 and Win10. So at the frame summary, when we filter it for ESP, it's just not going to show anything because we discontinued it because it was originally protected with ESP and now it's not. So we can exit out now that we verified that, right? That would take us to the end of our video. So now, just for a brief recap for the implementation of secure protocols, this is a pretty lengthy one, but it was also fun and very knowledgeable. I love it. So just for a brief recap of what we did, we worked with some domain name securities as far as those extensions, right? And we configured some IP security or IP security and also some security protocols as well towards the end there with the ESP and the network analyzing with the Microsoft application. So, but nonetheless, again, this is the end of this video. Definitely going to be back with another one. It's going to be securing an environment using mitigating techniques. I'll see you there.